Welcome to Otisam Mathematics. In this video, I'm continuing the series Sequence and Series. I'm done with arithmetic or linear sequence. I'm now on exponential or geometric sequence. So let's start. What is geometric sequence or geometric progression? This is a sequence whose terms are obtained by a constant multiple of the preceding term. In short, a sequence with a constant ratio. So this constant multiple is what is called common ratio, and we normally use R to represent that. So I have an example here. This is a sequence of numbers 3, 6, 12. And then 24. Okay, so now the first one, the first term is 3. Now 3 times 2, that is 6. So here 6 times 2 is giving us 12, and then the last one, 12 times 2, which is giving us 24. So the constant multiple that we talk about in this example is 2. So we can say that the common ratio is 2. Now, there's another way you can divide the current term by the preceding term. So 6 divided by 3 is giving us 2. 12 divided by 6 is also giving us 2. Then you can also check 24 divided by 12 is giving us 2. So that is the basic definition of exponential sequence. Let's quickly look at the pattern. We let the first term be A, and then the common ratio be R. Okay, so the first term is A. So if the common ratio or the constant multiple is R, then the second term will be A times R, right? And then the next term will be AR times R. Then the next one will be AR times R times R, and so on and so forth. So the pattern of the sequence is AR square, and then AR cube. You can guess. Can you guess for the next term? Right. Okay. So that is it. So look at the sequence carefully. So the common ratio lag behind by 1. Right. So here the second term. So you can see the 2 minus 1. And then the third term, you can say 3 minus 1. The fourth term, you can say 4 minus 1. R raised to the power 4 minus 1. So if you continue like this, then the n term will be A R raised to the power n minus 1. So therefore, the n term of exponential sequence or geometric progression is given by un, which is equal to A R raised to the power n minus 1, where A is the first term and then R is the common ratio. So let's use this to solve example 1. Find the n term of the sequence. This. So the n term, as we have gone through, un is equal to AR raised to the power n minus 1. Our A is the first term, so the first term from the sequence is 3. Now what is the common ratio? 6 divided by 3 is 2. 12 divided by 6 is 2. So the common ratio is 2. So therefore, the n term becomes 3 times 2 raised to the power n minus 1. We can go further. So un becomes 3 times by indices. You can split this one. 2 raised to the power n times 2 raised to the power minus 1. So we have 3 times 2 raised to the power n. And this one we can rewrite it as over 2. So 3 on 2 times 2 raised to the power n. That is the n term. Let's look at the next question. We are to find the number of terms of the sequence 2 plus 4 plus 8 plus up to 5, 1, 2. Now the first term is 2. Now let's see the common ratio. 4 divided by 2 is 2. 8 divided by 4 is also 2. So the common ratio is 2. Now remember, the n term is the same as the last term. So we have the last term to be 5, 1, 2. So the last term is given by a r raised to the power n minus 1. So this implies that, let's substitute the values. So 2 times the common ratio is 2 raised to the power n minus 1, which is equal to the last term 5, 1, 2. Now this is 1 from indices. A raised to the power m times a raised to the power n is, if the bases are the same, you add the exponent. So this one, on this side, we have 2 raised to the power 1 plus n minus 1 is equal to 5, 1, 2. So we have 2 raised to the power n is equal to 5, 1, 2. We want to find n. So we can express 5, 1, 2 in terms of 2. So 2 raised to the power n is equal to 2 raised to the power 9. Okay, the bases are the same. So we can say that n is equal to 9. That is our answer. Let's look at the last question. The third term of GP is 10 and the sixth term is 80. We have to find the common ratio and the first term. Okay, so let the first term be equal to A, then common ratio be equal to R. Okay, the third term. So how do you write the third term? AR we know the n term is equal to AR raised to the power n minus 1. So the third term will be AR 3 minus 1, which is equal to AR raised to the power 2. And then the sixth term will be AR 6 minus 1, which is equal to AR to the power 5. And we were told that the third term is 10 and the sixth term is 80. So knowing to the third term AR to the power 2 is equal to 10, that will be our equation 1. And then AR to the power 5 is equal to 80. That will also be your equation 2. We want to find A and then R. So let's divide equation 2 by equation 1. So we have AR to the power 5 over AR to the power 2, which is equal to 80 over 10. Now you do the same thing on the right hand side. And this A will cancel A, and from this indices, R raised to the power 5 minus 2 will be equal to 8. So R raised to the power 5 minus 2 is R cube. So we have r cube is equal to 8. So r will be the cube root of 8, and the cube root of 8 is 2. Knowing the value of the common ratio, we can find the first term. Now from r raised to the power 2 is equal to 10, we have a times 2 raised to the power 2, which is equal to 10. So 4a is equal to 10. Let me divide both sides by 4. So a, 2 will go here, 2 will go here, 5. A is equal to 5 on 2. So a is equal to 2 whole number 1 over 5. R is also equal to 2. So these are the values. That is the solution. Viewers, thank you very much for watching this video. This is the first part of geometric sequence.